channel Maths with Lazy B. In this video, we'll be discussing a question of Jee Mains 2024, which is from the topic of limits and derivatives, class 11th. So the question says that you have a differentiable function f which has the domain from 0 to infinity, where 0 is not included, to R, and we have been given this inequality. And this holds for all xy in the domain of f. So we need to evaluate this sum. So now to find this sum, you must be understanding that we need the value of the derivative of it. If that is there, then only we can proceed. And to find out that, we need to use this inequality. So the question is very simple actually. Since you are given with this, now you can see that it is having some form of the derivative. When you calculate derivative using the first principle, since f is defined from 0 to infinity, and let a be a point in 0 to infinity, now to calculate the value of derivative of f at the point a, you need this definition. You use this definition. Okay, so how to apply this to this? Now you can see that the numerator is already given. The numerator is already having some form here in the left hand side. So if you are trying to find out this, so let us say that we are evaluating the derivative at the point a only, and let x be a plus h and y be a, and substitute this here in this formula, and a is greater than 0, a plus h is also greater than 0, so it is in this 0 to infinity only. Now you can substitute the value of x and y here in star. So you are getting something of this sort. Okay. This implies now you know that using the property of log, you can separate the numerator and the denominator. So this was actually a. It was y, so it was a. Okay. Now how to find the derivative of this function at f at a? You need to divide it by h. Then only it will be matching at this definition of the derivative at a, this. So you just need to divide with h. So dividing by h on both sides. So Rh is greater than 0, so we don't need to worry about anything. It is not going to affect the inequality. So right now we are just dividing and applying the limit as well. When you divide this by h, it just becomes 1. So you can see that this when we divide it by h on both sides and then we apply the limit, you in the left hand side you're getting f prime a, and in the right hand side you're just getting the derivative of log, natural log at the point a, and since a is in 0 to infinity only, it is very much valid. A is also lying in the domain of our natural logarithm function. So this, and you know that derivative of our function, log function, is 1 by x. ln x is 1 by x. Derivative of ln x is 1 by x. So this is nothing but the derivative that we're calculating using the first principle, and you'll get this plus 1. 1 is as it is, and the limit, this is just the first principle applied for the function logarithm, natural log. So you get 1 by a. But this just gave you that f prime a is greater than 1 by a plus 1. But it is not giving you the actual value of your derivative of the function at the point a. Since you're not given anything else in the hypothesis, you need to use this only again. Now let us see what happens if we say that x is a and y is a plus h. This is just to reverse the inequality. Now let us see what will happen. Our x is a and y is a plus h. And we are given that fx minus fy is greater than or equals to natural log x by y plus x minus y. Substituting this over here, you get f at a minus f at a plus h is greater than or equals to logarithm a plus h plus a minus h. So this gets cancelled, and you can take the negative sign out to match the definition of the derivative. And using the property here as well. Now you can multiply with the negative sign on both sides. Now, then what will happen? This inequality will get reversed. So this is what is left out. This becomes positive, this becomes negative, and this becomes positive. Now the same thing, dividing by h on both sides. Now just taking the limit on both sides. Take limit tends to 0. So this is nothing but f prime a, and this is again the derivative of the log function at the point a. So this is 1 by a plus 1. Now, previously you were getting this, that f prime is greater than equals to 1 by a plus 1, and here you are getting that it is less than equals to 1 by a plus 1. So that means f prime a. So if your number x is actually greater than equals to 10 and less than equals to 10, so this inequality holds only if x equals to 10. If x is not equals to 10, then this is not going to hold, because not equals to, that means this is happening. So at the same time 10 is less than x and x is greater than, and x is also less than 10. That is not possible. Okay, so it won't hold. It is only going to hold when x is equals to 10. That means your f prime a is equals to 1 by a plus 1. So this is the derivative of the function f at the point a. Now you need to find out this sum. Now you are already knowing the value of derivative of the function f at any point. So to evaluate this, you know that f prime a is 1 by a plus 1. So using the same thing, we have now you can separate the sum. You get this, you get this. Here you are just adding 1 20 times. So 1 plus 1 plus 1 till 20. So you get 20 for this. And this, using the formula, you can easily find out the sum. The sum of the square of the first 20 natural numbers. So this is given by this formula, and you put n equals to 20 over here. You will be getting 20 into 21 into 41.6 plus 20. And this is 3778 20 equals to 2890, and this is your final answer. So thank you so much for watching this video. And if you have any doubts, please ask in the comment section. Happy learning.